Hello guys. So now we are going to discuss the applications of Ampere circuital law, and this is the first application. So in the first application, what we have basically, we have to find the value of magnetic field due to an infinite long straight current carrying wire. So we have to find that magnetic field. So let's say this is the cross section area of the wire, and wire is coming out. This is the cross section area of the wire, and wire is coming out from this screen, and the current is also coming out from the screen, and we need to draw the circle so that we can make the magnetic field line. So this is the magnetic field produced by this this is the magnetic field produced by this perfect magnetic field we have drawn. This is the magnetic field line produced by this straight current carrying wire, and now we have to take a small area, small length. That length is dl. So this small length is dl, and keep in mind the direction of the length is always in the direction of magnetic field. So since the magnetic field is anticlockwise, so the dl is also in the same direction. So, and at this point we have to find magnetic field. This is the point at which we have to find the magnetic field. I'm like highlighting this point. This is the point at which you have to find the magnetic field. So we need to join this point from the center. So we need to join this point from the center. So this is the radius. This is the radius. The radius is r. And now we have to draw the magnetic field at that point also. The magnetic field at that point you can draw by just drawing the tangent at that point. So this is the perfect tangent. B vector is the magnetic field, and dl vector is the direction of length. And you can clearly see the angle between b vector and dl vector is 0. So you can see एकदम clearly यहाँ पे दिख रहा है is the angle between b vector and dl vector is 0. So what is the angle? Angle is 0. So this is the angle 0. And because they have same direction, you can clearly see b vector and dl vector both have same direction. So therefore the angle between these two is 0. And now you can apply Ampere circuital law by ACL. By ACL we can write integration of magnetic field in a closed loop, integration of B dot dl. So integration of magnetic field in a closed loop is equals to mu naught times current inside the loop. Now you can open this thing. So then we got B dl cos angle is 0 mu naught I. Now because B is constant, because you can take any radius, you can take dl here, you can take dl anywhere, like you can take dl over there, you can take dl over there, like anywhere you can take dl. Radius is constant. Because the radius is constant, it means the value of magnetic field is constant if the radius is constant. So B is constant, so take B out. So we have B taken as out. Now we have only dl, and we left with 1, and this is mu naught I. Now what we have to do, apply the limits. So the minimum length of dl is 0 and maximum length of dl is 2 pi r, because complete circumference is 2 pi r. So the minimum length is 0 and the maximum length is 2 pi r. Now just put the value of limits. So upper limit, first you have to integrate. So 1 का integration होता है L, and then we have 0 से 2 pi r. Now you just need to put the limits. So B, then we have 2 pi r, and you can ignore 0 because 0 is 0, or you can put like this also, 2 pi r minus 0, and that is mu naught I. So what is the value of B we got? We got mu naught I by 2 pi r. So that's how you can find the direction of magnetic field due to an infinite long current carrying straight wire at a distance r from the wire. So that's how we can find the magnetic field. Now you can draw the graph also, like sometime they ask what is the graph as this is the y-axis, x-axis, and you can draw the graph. Like if you increase r, what will happen with b? You can clearly see b is inversely proportional to r. So when you increase r, b will decrease. You can draw this graph as an inversely proportional graph. This is the graph. So as r increases, b will decrease. So this is the graph. Keep in mind, this is the graph of b versus r.